Assalamualaikum warahmatullahi wabarakatuh. I will presenting chapter 15 about frequency distribution, cross tabulation and hypothesis testing of marketing research by Rizka Herlina.
Frequency distribution. Marketing researchers often need to answer a question about a single variable. For example, how many users of the brand may be characterized as brand loyal? What percentage of the market consists of heavy users, medium users, high users, and non-users? How many customers are very familiar with a new product offering? How many are familiar, somewhat familiar, and unfamiliar with the brand? What is the mean familiarity rating? Is there much variance in the extent to which customers are familiar with the new product? What is the income distribution of brand users? Is this distribution skewed toward low income bracket? Statistics associated with frequency distribution. As illustrated in the previous section, a frequency distribution is a convenient way of looking at different values of variable. A frequency table is easy to read and provides basic information, but sometimes this information may be too detailed, and the researcher must summarize it by the use of descriptive statistics. Measure of location. There are mean, mode, and median. Mean is the most commonly used measure of the central tendency. It is used to estimate the mean when the data have been collected using an interval or ratio scale. Mode is the value that occurs most frequently. It represents the highest peak of the distribution. Median is the middle value when the data are arranged in ascending or descending order. Measure of variability. There are range. The range measures the spread of the data. It is simply the difference between the largest and smallest values in the sample. Interquartile range. The interquartile range is the difference between the 75th and the 25th percentile. Variance and standard deviation. The difference between the mean and an observed value is called the deviation from the mean. The variance is the mean squared the deviation from the mean. Coefficient of variation. The coefficient of variation is the ratio of the standard deviation in the mean, expressed as a percentage, and it is unitless measure of the relative variability. Measure of shape. There are skewness and kurtosis. Skewness is the tendency of the deviation from the mean to be larger in one direction than in the other. Kurtosis is a measure of the relative thickness or flatness of the curve defined by the frequency distribution. A general procedure for testing hypothesis. Formulate hypothesis H0 and alternative hypothesis H1. Select the level of significance. Determine the probabilities associated with the test statistic under the null hypothesis using the distribution of sample statistical test, or determine critical dimensions related to the test statistic that divide the rejection and non-rejection areas. Compare the possibilities associated with the rest statistic with the specific level of meaning. Alternatively, determine whether the test statistic has fallen into the realm of rejection and non-rejection. Make a statistical decision to reject or non-reject null hypothesis. State a statistical decision in terms of marketing research issues. Cross-tabulation. Although the answer to a question relating to a single variable is very interesting, it often adds one question variable about how to link that variable to another variable. Two variable. Cross-tabulation with two variables is also known as bivariate cross-tabulation. Percent calculation can provide more insight. Three variables. The introduction to the third variable explains that the initial association has been observed between two variables. General comment of the cross tabulation. More than 3 variables can be alternated, but the interpretation is quite complicated because the number of cells increases exponentially. Having enough respondents or cases in each cell can be a problem. As a general rule, there must be at least 5 observations expected in each cell for the calculated statistic to be trusted. Statistics associated with the cross tabulation. In general, the strength of an association is interesting only if the association is statistically significant. The strength of the association can be measured by the correlation P coefficients, the contingency coefficient phi Kramer, and the lambda coefficient. There are chi-square contingency coefficient and P coefficient. Chi-square statistics are used to test the statistical significance of the associations observed in cross-tabulation. This helps us determine whether there is a systematic relationship between the two variables. Contingency coefficients. Contingency coefficients P-specific coefficient are in the 2 times 2 table. The same coefficients can be used to estimate the absorption strength in a table of any size. P coefficients. The P coefficient is used as measure of the strength of the association in the special case of a table with the 2 rows and 2 columns table. There are Kramer's phi, lambda coefficients, and other statistics. Kramer's phi is a modified version of the P coefficient and is used to the table larger than 2 times 2. Lambda coefficients. The lambda coefficient assumes that the variable is measured on a nominal scale. A symmetric lambda measures the percentage increase in predicting the value of dependent variable, given the values are independent variables. Lambda also varies between 0 and 1. Other statistics. Note that in the calculator from the chi-square statistic, the blade is considered based on other nominal statistical scale. All of these statistics use information about ordering variables categories by considering every possible pair of cases in the table. This is the cross-tabulation in practice. There are one sample, two independent samples, and paired sample. One sample in marketing research, the researchers are often interested in making statements about a variable that is able to go against a standard that is known or given. Two independent samples. Some hypotheses in marketing are related to the parameters of two different opportunities. Paired sample. Paired sample in many marketing research applications, observations for the two groups are not selected from independent sample. Instead, observations are related to paired sample in that the two sets of observation relate to respondents. There are non-parametric tests. One sample, coupling sample, and two independent sample.
Chapter 16, Analysis of Variance and Covariance. Relationship among techniques. Analysis of variance and analysis of covariance are used for examining the difference in the mean values of the dependent variable associated with the effect of the control independent variables after taking into account the influence of the uncontrolled independent variables. Essentially, analysis of variance ANOVA is used as a test of means for two or more populations. The null hypothesis typically is that all means equal. One-way analysis of variance. Marketing research are often interested in examining the difference in the mean values of the dependent variable for several categories of a single independent variable of vector. Statistik terkait dengan analisis satu arah varians. Eta2 atau H2 mean square, SS between, SSY, F statistic, SS within. Conducting one-way analysis of variance. Identify the dependent and independent variables, decompose the total variation, measure the effects, test the significance, interpret the result. Assumption in analysis of variance. Assumption in the analysis of difference. The silence assumption in the analysis of difference can be summarized as follows. Usually, this category of independent variable is assumed to be correct. Conclusions are made only for the specific categories considered. This is called the fixed effect model. Other models are also available. In the random impact model, categories of treatment are considered as random samples of the universe of care. Conclusions are computed to other categories not examined in the analysis. A mixed effect model is successful if some treatments are considered permanent and others are random. The term error is usually distributed with zero intention and constant difference. Errors are not related to either categories X. Simple difference from assumption do not seriously affect the validity of the analysis. In addition, the data can be changed to satisfy the same assumption of normality or diversity. Other errors are not related if error terms are correlated. N-way analysis of variance. In marketing research, one is often levered with the effect of more than one factor simultaneously in determining this effect, and variance analysis methods can be used. The main advantage of this technique is that it allows researchers to examine the interaction between these factors. Interaction occurs when the effect of the factor on a dependent variable depends on the level or category of other factor. Covariance analysis. In this section, covariance examines the difference in mean values of the independent variables controlled therein. Various gain. At ANOVA, F only checks the overall difference in the average. If the null hypothesis of the same group mean is rejected, we can conclude only that not all group means are the same. Multiple comparison. The ANOVA F test only checks the difference overall. If the assumption is empty, it means it is rejected. It can be concluded that not all groups are the same. There are only a number of ways that may be statistically different and can be checked by setting an appropriate comparison or with a comparison used to determine which of the methods are statistically different. Recalculate ANOVA. In marketing research, there are often big differences in the background and personal characteristics of the respondent. Non-metric analysis of variance. Non-metric analysis that examine difference in the main trends of more than two groups when the dependent variable is measured on an ordinal scale. One such procedure is the K-sample median test. Multivariate analysis. The aim is the same, namely ANOVA also helps by examining difference between groups. Since ANOVA examines group difference on one dependent variable, ANOVA checks group difference across several dependent variables simultaneously. Hypothesis test. Basic concept of hypothesis testing. The Drug and Food Control Department will approve the launch if it is proven that the drug is effective. To find out the efficacy of the drug, a randomized sample of 100 middle-aged men was carried out. Each sample participant was given the drug at the recommended doses at specific intervals, and their cholesterol levels were measured periodically. Zero hypothesis and alternative hypothesis. The statement about effectiveness or not is called a hypothesis. In line with two possible types of government decision, there are two kinds of hypotheses in this regard, namely 1. Ineffective medicine. 2. Effective medicine. Possible mistakes on hypothesis testing. Because in testing this hypothesis, we use sample data to explain the state of the population. There is a possibility of error from each conclusion made. Hypothesis testing and average parameter mu. Formula HO and HA call the type of the test. The two major parts to this type of testing, namely side testing, left side, right side, double-sided testing. From the various testing alternatives, only one was chosen in accordance with the existing problem. Determine the real level alpha to be used. The error rate when reciting the wrong HA. Determine the appropriate test statistic. Find the critical value from the required table. Compare test statistic with critical values. Make a conclusion based on the comparison in point 5. Test average if large samples or population variation. Appropriate test statistic. Critical values seen from table Z. Critical values with problem table Z. When testing the left side. When testing the right hand side. When testing two sides. Average testing if the sample is small and population variety unknown. Appropriate test statistic. Critical values from the t-student table. When testing the left side. When testing the right hand side. When testing two sides. Testing the difference between two parameters mean. An average of the populations can be compared by looking at the difference. If the difference is negative, it means that the average of population 1 is smaller than the average population 2 and vice versa. Testing the difference between two average if a large size sample or if the population standard deviation both are known. Appropriate test statistic. Z calculate. Critical values in from the Z table. When testing the left side. When testing the right hand side. Testing the difference between two average parameters if the sample size is small and the standard deviation of the population is unknown but can be considered the same. Appropriate test statistic. Critical values can be seen from the t-student table with when testing the left side. When testing the two sides. When testing the right side. Testing the two mean difference hypothesis or paired data. Similar to parameter estimation, samples taken from all populations that are not mutually free are called paired data. So the current is calculated first the difference between pairs, then testing is done. Testing proportion parameters. Proportion hypothesis testing is very widely used in statistical application given the magnitude that is important for various managerial situations. The use of proportion is often found in quality assurance testing, testing the acceptable level of error in the production process, in marketing decisions related to the proportion of product users in various process segments, and so on. Hypothesis testing difference into parameters proportion. The test is done if we want to compare the proportion of two populations to find out whether proportion 1 is greater than population 2 or vice versa. Testing of various methods. In many situations, decision makers are often confronted with the question of how far variation in a population are. For example, variation in the time of doing something. Hypothesis testing regarding a variety matter in a population with a variation of the statistic. Appropriate test statistic. When testing the left side. When testing the right side. when testing two sides. Testing the similarity of two variants of the population. When testing the left side. When testing the right side. When testing two sides. If the F tables there's no F value at a certain free degree, the following transformation can be performed. Thank you.
Here I answer the question in book chapter 8. The first question, the following data are the number of walks per minute referred by for secretaries using for different electronic tachometers. Next, the answer. The first, y is to count literally. The second step is to count down. Next, JKB, JKB, JKS. This is all the formula from there. Next, JKB 275, 225, so on, obtained from the table. JKK, this is the same as JKB if JKK is used the total bottom. Next, JKT. Calculate the data in the table Ayu, Bella, Sandel, Ardini. Next, JKS. This is obtained from calculating the total number of JKK, JKB, JKP, JKT, JKS. This. Next, testing the effect of the number of keystrokes per minute due to difference in secretaries. We count greater than feasible, so reject hope. Conclusion: there is an effect of the difference in a secretaries on their per minute typing. B. Testing the effect of typewriters on typing per minute. We count smaller feasible, so achieve of conclusion. There is no effect of the difference typewriters used on their per minute typing. Next, the two question. The first step is countdown. Next, is countdown. Next, T is number of result and data in table. This is next, the total T together with T1 plus T2 plus T3 plus T4 together with 55 plus 61 plus 76 plus 54 together with 200 of D6 decision reject ho algebra because F arithmetic F greater than feasible. Conclusion: there are differences in the influence of credit asset on the use of money spent by housewives.
Now I will discuss how to do univariate analysis of categorical data with SPSS. First, prepare data to be analyzed. Then open the SPSS application and click the variable view. Then in the first name column, type H and then in the decimal section, change to 0. Then in the label column, you can type with mother's age. Then in the second name column, type education and then in the decimal section, change to 0. Then in the label column, you can type mother's education. Then go to the data view. Then move the existing data into the SPSS application. In the education data, only the score portion that has been transferred is based on the mother's education level. Then back to the variable view, and in the second value column, we enter the coding that we have given based on the mother's education level. Then go back to the data view, then click Analyze menu. Select the descriptive statistic, then select the frequencies, then move the mother's education in the left column to the right column, then click OK. And you will get the result. Now I will discuss how to do the validity test with SPSS. First, prepare the data that has been obtained and then open the SPSS, click variable view. Then in the first name column, type item 1. And so on until item 9. and the last column type score total. Then the decimals are changed to 0. Then input data that has been obtained into the data view. Then to test the data, first open the Analyze menu. Then select the Correlate section. Then select Bivariate. Then in the correlation coefficient section, check Pearson part and checklist also the flag significant correlation section. Then select all item in the column on the left, then move to the right column, then click OK. Then you will get the result of the validity test. Then to do a reliability analysis, the steps that must be done are: first, select the Analyze menu, then click the Scale section, then select Reliability Analysis, then move all item to the right, then click Statistics section, check the scale, if item deleted section. Then click Continue, then click OK. And you will get the result of reliability analysis. Now I will discuss how to do bivariate chi-square with SPSS. First, prepare the data to be analyzed, then provide the code in each category in the data. Then open the SPSS application. Then click the variable view. In the first table, name is filled with the area, and the second table filled with economics. Then the decimals column is changed to 0. Then the first label table can be filled with the area events. and the second label table can be filled with economics. Then in the values table filled by code that we given to each category. Then in the measure column for the area, the measure scale is changed to nominal. And for economics measure column is changed to ordinal. Then open the data view. Move the code from each category that we have into the SPSS application. Then open the Analyze menu. Then select the descriptive statistic. Then select the cross tab. Then the independent variable is entered into the row column. And the dependent variable is entered into the column table. Then click the statistic menu on the right and check the chi-square section. Then the nominal part. Check the contingency coefficient section. Then also check the recession at the bottom. Then click continue. Then in the sales section, check the row section. Then continue. Then immediately click OK. Then you will get the result.